Okay, so I want to do a quick introduction to logarithms. This is, just going to be really short and sweet here. One way to define a logarithm is to think of it as the number to which you would raise a base to get a target number. So if you look at the example right here, when you write log base 2 of 8 equals 3, log base 2 of 8 is 3, because if you took 2 and raised it to the third power, you would get an 8 back. Or in other words, let me kind of break it down for you like this. So if I have a logarithm, my base is going to be right here. It's going to be this little number here. Actually, let's just call that b for base. That'll be good. And the exponent that I would raise b to goes off by itself. That's what you end up calculating a lot of the time. And the number here that you're taking the logarithm of is your target. So we have our base, we have the number we raise the base to, and we have the target. So let's actually do some examples now. So if I want to find log base 3 of 27, and I want to know what that is, so let's call it x because we don't know what it is. Well, I'm going to rewrite all of this in what I would call exponential form. So if this is logarithm form, exponential form would look like this. 3 is your base, x is the number that you're raising it to, and 27 is your target. So target, base, exponent that you're trying to raise it to. And then to solve this problem, you just think backwards. So what do I raise 3 to get 27? Well, I think I have to raise that to the third power, because 3 to the third is what gives me 27. So let's do another example here. Let's say I have log base 5 of 25, and I want to calculate that. So I'm going to set it equal to x so that I can write my exponential equation. And then 5 is my base. X is the number to which I would raise 5. 25 is my target. And then if I write it this way in exponential form, it's very easy to see that x would have to be 2 to make this equation true. So my final answer is x equal 2 there. Okay? Now let's do one more example where maybe what I don't know is the thing in the middle. Whoa! So let's see here. So let's say I have log base 2 of x equals 6. Okay? So to solve this one, again, just write it in exponential form. So 2 is my base. This time 6, the exponent, is known to me. And x is what I don't know, and it's the thing in the middle here. It's my target. So 2 to the 6th is 2 times 2 times 2 times 2 times 2. Well, you get the message. 2 times 2 times 2, 6 times. I think that's going to give me 64. So my answer here would be 64. You can also do problems where the base is what you don't know. But, and it's pretty much done the same way. You just plug in the 3 numbers in the correct spot and go from there. So hopefully you found this helpful. Like I said, this is a really quick explanation for logarithms. I don't want to go into a lot of extra detail. Basically, you can use logarithms. Oh, one other thing I need to tell you. If I do a logarithm without a number, usually a logarithm without a little base down here, usually if there's no base written, it is understood to be base 10. We call that the common logarithm. So if I wanted to solve something like this, where the 10 was not given to me, then the way I would solve it if that 10 is not given me, you just understand that if there's no base given, 10 is the base. In this example, x is my exponent, and 1,000 is the target. And this one's actually very easy. When you're dealing with log base 10 and they give you a multiple of 10 like this, I think it's pretty easy to see it's 10 to the third. So x equals, so x equals 3 because 10 to the third gives you 1,000. But kind of a shortcut for this one is to just notice that your answer is going to be the number of zeros you have. Now, like I said, that only works if it's a power of 10, like 10, 100, 1,000, and so on. And also, don't forget your base would have to be 10 to make that work so easily as well. So that's all I want to talk to you about logarithms. Again, you can do a lot more with logarithms than that, but there's a quick, short example for you, and I hope you found it helpful.